Hi, welcome to checkpoint 12. We're going to start at the very bottom with question 10, and I have the unit review and theorems up so that we can use it as a reference point. So question 10, line A intersects line B at point P. Points J, P, L, and K are on line B. Points G, P, and H are on line A. Line C also intersects lines A and B at point P, but shares no other points with either line. Vector LM, M is a point on the interior of angle GPJ, which is a right angle. It is given that segment JP is congruent to segment PK. Which of the geometric figures pictured is not a perpendicular bisector of JK? Okay, so perpendicular bisector means that it forms a 90-degree angle and that it cuts the segment in half. So from the information that was given, we know JP is congruent to PK. So JP is here, that is congruent to PK, right there. We also know that this angle GPJ is a right angle. And from the perpendicular lines, if you have a perpendicular line, then all four angles are perpendicular. So we know all of these right here, angles formed between line A and line B are 90 degrees. So they want to know which one is not a perpendicular bisector. So, well, which one is? So line A and any segment that is on line A is going to be a perpendicular bisector. So is line C part of line A? No, so it's not a perpendicular bisector. Is segment JK part of line A? No, segment JK cannot be perpendicular bisector to itself. Line A is the perpendicular bisector. Segment GH. Well, points G and H lie on line A, so it does form a perpendicular bisector segment. Vector LM is not on line A, so that part is not a perpendicular bisector. Question 9. If segment AB is a perpendicular bisector of segment CD, then the measure of angle AEC equals blank. Okay, well, if it's perpendicular bisector, then the measure of A to E to C, this angle right here, since it's perpendicular, is 90 degrees. And that's just knowing the definition of a perpendicular bisector, or perpendicular for that matter. Okay, question 8. Line A intersects lines B and C at point A. Points G, A, and H are on line A. Points J, A, L, and K are on line B. Angle JAG is a right angle. Point M is in the interior of angle JAG. And vector LN is constructed through points L and M such that vector LM intersects line B and at L. Okay, given that AJ is congruent with segment AK, which figure is a perpendicular bisector of segment JK? Okay, so this was similar to 10. The perpendicular bisector means it's at 90 degrees and it cuts it in half. And we know from A to J, that's congruent with A to K. So what point goes through the midway point, which is A? What line goes through that? And line A goes through the midway point. So line A is going to be a perpendicular bisector to line B. And any segment of line A will be a perpendicular bisector to segment JK. So since G and H are points on line A, segment GH would be a perpendicular bisector as well. To use the figure to answer the question, the design shows the flag case that is in the shape of a triangle with a height that is a perpendicular bisector to its base. What is AC's length? Okay, so we know that it's perpendicular bisector, which means it's 90 degrees, and that it cuts the segment in half. So BD is half of the total length of BC. So that means from DC is 3. There we have two sides that are the same. So for triangles to be congruent, we have side, 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 angle, or angle, side, angle option. And right now, we're given a side and an angle. And we know that the perpendicular lines, if two lines are perpendicular, then their intersection forms right angles. So this angle is 90 degrees as well. So we have a side, an angle, and AD, since it is a side to both of the triangles, is congruent to itself. So we have side, angle, side, and side, angle, side congruent. So the corresponding part to AC, that was our goal, corresponding part to AC is AD, which is 4.24. So our answer is 4.24. And then it says use the figure to answer the question. If segment AB is perpendicular bisector of segment CD, then the measure of angle BED equals what? Well, BED is through our intersecting point of our two perpendicular lines, so it's going to be 90 degrees. And before we move on, I'm going to actually jump to the proof. Before we move on, I'm going to share with you the answer, and it's again by Marissa Peer, who is a renowned hypnotherapist in the UK, and she has come over to the US a couple of times and helps with celebrities, so she's our celebrity therapist. And she has 5 tips for how to avoid rejection, and the first one was say thank you for stating that, and that's going to dissipate things most of the time. And then if they keep going at it and just keep stating, well, say you cut your hair. Well, your haircut looks awful. And you would say, thank you for saying that. It really does. It looks terrible. And then you would say, well, would you repeat that again? Except for this time, say it slowly, because I didn't quite catch that. And what you're doing there is, by asking them to restate it, it gives them time to think about what they are saying, and the majority of the time they will retract what they said. They'll just brush it off. Oh, just ignore what I'm saying. I'm having a bad day, or they'll try and take it back. And then you have to let it go as well and not egg it on. And so the first 2 steps would be saying thank you for saying that. And then if they keep going, then you just say, please say that again, because I didn't quite catch it. And say it slower. And then if they do retract it, let it go. And if they don't, you'll find out what to do next. So question 4, complete the following proof by filling in the blanks. Segment AB is congruent to segment AC. D is the midpoint of segment BC. So I'm going to look for an example that gives a similar scenario. Okay. So we have that we need to prove A is on the perpendicular bisector of segment BC. So let's go through this. AB is congruent to AC, that is given. D is the midpoint of segment BC. What's the reason? Well, the reason is it is given because it was stated in the given section. So we would type in given and then a comma. That's reason one. And then segment BD is congruent to segment CD. That's the definition of our midpoint. Segment AD is congruent to segment AD, the reflexive property. And then they're saying triangle blank is congruent to triangle ACD. So we have to look at what order are the corresponding parts. So they went in the order from A to C to D. So because BD is congruent to CD, I know that the BD has to be the second side or the second segment. So where is our starting point? Do I go from A to D? So BD is our second segment. The first segment is A to D, A to B, A to B, B to D, and then D back to A, because they stated that AD was congruent to itself. So triangle ABD in this order is going to be congruent to triangle ACD in this order. So then we are going to capitalize it and say ABD. ABD. There we have it. Another good tip maybe would be to write down one of these once you know you have it right and add it to your notes so you can use it on the exam as an example. So, question, let's see, there's another proof. Okay, let's do question 1. Triangle ABC is an isosceles triangle with base BC. Segment AD is the perpendicular bisector of segment BC. Prove that angle B is congruent to angle C. So, complete the following proof by deciding if reason A is correct. If not, choose the statement that should replace it. Okay, let's go through and see what they are using then, and see if it's correct. Okay, so triangle ABC is an isosceles triangle. That's given. Segment AD is the perpendicular bisector of segment BC, which is given. Segment BD is congruent to segment CD. That's the definition of the bisector. So BD is congruent to CD. Angle BDA is a right angle. So BDA, that means the one in the middle, is a right angle. That's our definition of perpendicular. Angle CDA is a right angle. So CDA, the angle they're talking about, is in the middle. That's the definition of perpendicular. And then they're saying that angle BDA is congruent to angle CDA. Right angles are congruent. And then they're saying segment AD is congruent to segment AD because it's the same length. It's the same side. So then they state triangle ABD is congruent to triangle ACD by the angle side angle congruence theorem. Well, do we have two angles in one side? No. We have two sides. Segment BD, side BD, is congruent to side CD. We have the angle BDA, angle CBA, and we have a side length, AD. So we actually have side, angle, side. Side, angle, side. So we are using the side angle side congruence postulate instead. And there is your help.